But
So there is
we
no
should never
change.
have a situation in the program that we're going to create, though, because we're only going to ask for a number in between what
0 and the number of
which
nodes.
is basically we find out by count.
Yeah.
Okay. But okay.
But for it's good programming practice to now which nodes have to handle that exception? Which nodes are the ones that are going to be throwing the exception?
Just the constants.
The bottom ones.
Just the bottom ones, so just the variables and just the constants. So the ones up here don't need to throw an exception because they're always going to have someone they could pass it off to. Okay, today's the day when I think I feel confident that we can start the end game on this, which is I'm going to give you. I was up last night working on it. I had these grand plans for I was going to refactor it all into a bunch of interfaces and abstract classes. I'm just going to clean up the code I got. I'm going to say I'm going to give you the minimum, and you can improve from there. So I want to spend some time walking you through what my piece of the program does and how you're going to have to hook in your pieces to make the robot do what it's supposed to do. So the first thing I need to do actually is go get the latest version of this. So give me a few moments here. What can we do here?
Actually, just open
This is going to take a few minutes, so maybe here's something to think about. This is your robot, and these are the 3 targets it needs to hit. Right now, my fitness function, the thing that determines what score this robot gets, adds up. Let's see, let's put in a path here. Let's say it follows this path. It records all the points that this robot went on, and then finds out what was the closest the robot came to each one of these targets. So basically it runs through the path, and it figures out what was the closest it came to this target. And then it runs through the path again, what was the closest it came to this target? What was the path, it runs through the path again, what was the closest it came to this target? So this number here might be, let's say, 20, this one here is 3, and this one is 10. And it just adds up those numbers, and that becomes the score for that robot.
Didn't you average this?
No, I think I ended up just summing it. I think that worked better. And also I have it so that if it does reach one of the targets, it gets another chance to go on and get the other one. So it gets 100 steps to find one of the targets. If it doesn't find one of them within 1,000 steps. If it doesn't find it within 1,000 steps, at that point it's done. But if it finds one of the targets within the first 1,000 steps, that target is removed, and it gets another 1,000 steps to find the next one. So kind of like I said last time, it's kind of like it gets them food, and it's able now to survive for another 1,000 steps. So we add these up, and we get 3, and that becomes the score for this. So what are some of the shortcomings of this? Because if the path was that, it gets the same score. But it lives.
Find the shortest way.
So it doesn't reward it for finding the shortest path, it only just rewards it for finding them. So how can we adjust the scoring so that it gets rewarded for doing it as quick as possible.
Had the amount of steps it took to get to the spot where it's the closest to each one of those spots. So like if it took 50 steps to get to the first dot and it was 3 away, it'd be 53. And if it took however many steps from that first spot to get to the second spot, add that to the next amount. And the shorter you get, the better the path is.
What would the kind of formula be for that? How do you work in the number of steps it took?
Account on your function.
So right now this is minimum distance to the first target plus minimum distance to the second target plus minimum distance to the third target.
Divided by total steps taken.
Divided by total steps taken. So the more steps it takes, the lower its score. But the goal here is to get this as close to 0 as possible.
Well, a perfect score would be, oh yeah, so if you got all zeros, then you'd be dividing, I don't know.
Well, so if you divided this by, it took a total of 1,500 steps, then you get one score. If it came just as close, but it now took 2,500 steps, you'd actually get a smaller score.
Yeah,
This
lower.
is better.
Wouldn't it be lower? 33, 2,500 is smaller than 33,
Right.
1,500?
But if we want to minimize this number,
You could,
Oh, we're playing golf, so the lower scores are better?
yes.
Okay.
you could divide it by steps left.
Multiply it by steps taken.
Well, multiplied by steps taken?
So
don't
if you
know,
can get
I-
33 and take one step, that's pretty darn good.
Well, yeah.
I think the first thing that I see is a problem with trying to do something like that as a compound system is that you want each evaluation to have a certain amount of weight on the process. So things like getting to the target should have a high weight, and taking a less amount of steps should also be relevant, but have less weight.
So can we come up with a formula that gives us a good score, so the target is to make it, again, like golf, to make it as low as possible?
Maybe like at a point for every step taken, but have the closeness score be multiplied by like 10 or 50 or something.
So the closer you get, the better?
Well, the closer you get to the target, the less, because like right now you have a distance of 20 as your first score, right?
Mm-hmm.
So if you were to multiply that by 50, then that would be 1,000 points. That would be the same as using your entire track of energy. But you also get rewarded for, like if you only had distance of 10, then that would be 500. But you also get rewarded for taking the fewest number of steps possible. But number of steps has much less weight than distance from the target at the
So it's better to be closer than it is to
right.
take more
but
steps.
taking fewer steps is still valuable.
Yeah. You had your hand up a few minutes ago.
Well, I was just thinking you'd want to find like first how many steps it would take to just linearly reach each target, and then use that value, and then you could just take turn the whole plane into the graph, and then have each point value a certain amount of points depending on how far it is from each target, and then where the robot stops on those points, that space is worth like a value, and the further away, the more points it has, and then like the closer, the less points it has.
So you say if I find these distances,
Yeah, you do that.
and then the goal is to minimize the difference between how long it actually took you versus
Yeah.
the real distance? Okay. So I want you to think about those things. Mine just simply scores you based upon how close you got to the targets, but doesn't reward you for doing it quickly. The only reward you get doing it quickly is the fact that you lived.
So is the goal to hit each target individually, or to hit all 3 targets in one run?
All 3 in one run. Pick up as much food as you can.
That's the turtle that lives for 3 days.
Yeah.
So then you need the distance of all the vectors, magnitudes, rather than the...
So you may not want the distance from the starting point to each one of these. You may want the distance the ideal route would be to go this one first, then this one, this one.
Yeah.
Just put a crap load of
You
food
should-
over there, and then the winner is the one that picked up the most food.
That's an idea. Just put a whole bunch out there and just reward them for finding them.
Yeah, so the one that picks the most food, he's the survival for the next generation. And you try to get as many as
So
possible.
you could flip the fitness function around. You could say the goal is to get as many as possible.
Yeah.
So to make that number as high as possible. That's just changing a less than to a greater than in the program.
I was thinking like 1,000 out there.
Yeah, it doesn't have a preference over which it goes to first at all.
No. But if you can reward it somehow for finding the closest one first by factoring that into the score, then it should just eventually find the closest one sort of by trial and error. And the one that finds the closest one first is the one that wins and goes on to produce more. So you're not really teaching it to find the closest one. It just learns that that's the best way to minimize its score.
Kind of like old Pavlov. He wasn't teaching the dogs about electricity, he was just teaching them that it didn't hurt when they laid down.
Was that Pavlov's experiment?
I'm pretty
It
sure
differs
Ron
from the one I remember.
That was part of it.
That was ringing the bell for.
He did a bunch of different experiments, but
No, he only did one experiment, that was it.
only one, that's the only one that ever.
We're tired, you gotta You just like to abuse dogs. He was an animal abuser. I mean, in today's day, he'd be in jail.
PETA.
After Michael Vick was there.
Almost done. It's gonna work here. Let me just make sure. Want to turn on some lights? Here we go. So I got 4 targets on the screen. I still don't know why these sometimes zip up to the top left corner. I suspect that's just a bug in the drawing routines that I'm using because I put in some debugging code there to find out, does the turtle ever actually go up into this corner? And no, it doesn't. So it's just somehow, it's drawing those lines even though it never actually goes there. Down here, I have it running the robots, and I take the 4 best ones. So there's 0, 1, 2, 3, and 0, 1, 2, and 3 being shown here, but it's only showing you 1, 2, and 3 because the 0 scrolled off.
Whoa. That's a pretty straight line.
I'm gonna go away this bit here and bring this up. Here we go. test this last time, but, and so, oh, there's the best one.
Wow.
That's actually really good.
Couple circles there, 3.
Damn
Wow,
close.
okay. So when it finds that fourth one,
Uh-huh.
well, that's kind of weird. So it found 1, 2, 3, 4, and then decided to find the fifth one again. The fourth,
Started here,
yeah,
found this one.
yeah,
This one gets taken away.
it's done,
So now it found this one.
done.
This one gets taken away. So it went up and found that one.
Actually, did it really find it? Because it came back to it. Maybe it didn't find it, just went around.
Maybe it didn't.
Because I took it. You were right there.
Oh, that looks like the ending
It
there.
was close, but I don't think it actually did.
After the
Yeah.
fourth point, it went down there with its last 1,000 steps.
Well,
and
what
just-
may have happened was, as it was coming toward it, remember, it gets this sensor strength depending upon how in front of it, the thing actually is. And so I saw one case where it was kind of like, it was heading sort of towards one of the targets. It was kind of curving towards one of the targets, and then as soon as the target was right in front of it, when that sensor strength was as strong as possible, it went
Didn't see it anymore?
No, it's like the function acted a lot differently when the highest number was being put in there. When the number went over some threshold, it told it to turn a different direction, and then at that point, it couldn't see it anymore.
That might be.
So I think that what might have happened here was you see it started to curve towards that, and then suddenly it's like right in front of that thing, and it goes, and it turned away from it at the last moment.
Run it again.
Anyway, so it goes around, found this one, and then maybe came back to this one, but why did it circle?
Still in steps. Because
Because
it
it
didn't
has
touch.
Steps left to go.
It's got some steps left to go, and now it doesn't see any,
So it just keeps turning.
so it just keeps turning. Want to see it again?
Yeah.
Both those.
All those turns seem to have the same radius, is that true?
Whoa.
Which turn?
After it found its first target, then it made the turn to the right.
Yeah, because they're all using the
and then
same
it found
function.
the second
right?
No,
target, and then turned
random.
again.
No, the one that hit all of them had the same arc in all the turns.
Oh, yeah, probably because
It's just using
it's using the
that.
same function, so as soon as one of them
Oh.
disappears, then it goes into its scan to the next one mode, which is always turning at the same rate.
It's just abstract art.
It's got Mickey Mouse up there.
It was colored. Some color now.
I like the clouds.
A lot of squiggly lines. Look at that where it went around.
Apparently no one cares about that middle food.
Yeah, the middle one doesn't matter. It's neglected.
Why would that be?
Because it can't get seen after it hits that second dot.
It's seeing the other ones first.
So, yeah, this one's always turning left, so it turns left and it sees this one, and then it turns left and it sees this one, and it turns left and it sees this one. And then, for whatever reason, it's not able to then turn around and see that last one.
It will eventually.
Maybe.
Interesting thing happens here is you start ending up with functions that like the 4 best ones are all exactly the same. Or just have minor differences between them, but you see the scores are all, well, they were in the previous generation, all about the same. So that happens in biology too, that you get sort of a generation of organisms that are all pretty good, and those tend to just reproduce and reproduce. So the entire herd is now just like that one, but then the mutations start coming in again, and then at some point you get one that's a little bit better. And so that one starts taking over as the best ones.
Oh, you got it. You got
There
it.
you go, there's that generation all the same.
Oh, it's so close.
Yeah, so you got a whole generation of them that they have minor differences between them, but they all score the same.
Middle one got hit.
Yep.
What a crazy.
This is interesting. What does it do? Go Go to this one, and then
Maybe that one like gets crazy with those switches.
Makes a ricochet.
I'm drunk.
I don't have enough
So it
steps
needs to
get
get,
down
what,
there.
it needs to get under 20 when you have 4?
How can we continue going?
because you get under 10 no matter what.
Oh, okay.
So,
That's
because
why you don't drink and drive.
So it just kept going
because it
after
didn't
the,
hit circle at the end, that means it barely made it.
Oh, over here?
yeah.
Oh, no, I thought, okay, I thought a circle was at the end. I thought he started,
It does have circles at the end, it's just, they're really, really tall, or
Small.
tiny. Yeah. Okay.
And my guess is that because I have tangent as one of my functions in there, you know, tangent is a periodic function, so it's probably doing circles embedded with some kind of tangent thing that causes it to kind of spiral around and
so you're using tangent instead of sine, or did you throw sine tangent?
I threw sine away and tried tangent, because that gave sort of this sense of this snaking behavior,
Versus
whereas sine, because you only get a number between -1 and 1, it kind of made the output of the function less interesting, whereas tangent, the output is
infinity.
Negative
-infinity to positive infinity, so now it allows big numbers to show up in my functions, whereas sine tend to kind of compress it down into a small range. But that's all things that you could experiment with. Let's try throw different functions in there. I didn't do power at all, exponent. You guys could try doing that, see what happens. Some of you are learning about hyperbolic signs now in your classes, right? Try those. So here's the class. It's called stage. It just extends JFrame. I've put up at the top here the goal number to reach. That's so anything under this number is considered the program's done. At that point, we found the best one. So whichever one can get under 10 wins. So that happens to be this one right here. This is how many to keep from each generation. And then this is just a counter that counts up how many generations, so that's just that number right there. Okay? What is, yeah?
Can you tell me a little more about final, double, or final?
Oh, final just means it's a constant.
Oh,
Can't change it. So, you can set it once, and then that's it. Okay, what does the constructor do?
sets the stage.
Sets the stage.
It opens up the
Makes a
size
window.
of your screen,
Uh-huh.
sets the title of your screen,
Yeah.
makes new canvas.
Changes
Basically, it sets up your draw screen.
Yeah.
Sets
And it
the
makes it so that if I
default
click
close
on
upper.
the close window box, the whole program exits.
What do you mean by this generation?
Well, I certainly didn't mean Pepsi generation.
Did you mean my generation?
It's this variable here.
Okay. Oh, okay.
Just means that stage.
Yeah.
Here's the main. It creates one of itself, finds the best function by evolving a bunch of them, and then prints it out. So where does all the work get done?
Stuff.
everywhere else.
Function.
Which one? The constructor, evolve, or print line?
Function.
Everything gets done in best.
That's where all the real work's getting done.
Yeah,
Yeah.
8.1. There. Program done. So it's all getting done here. Let's go look there. Where is, evolve. Create 100 random functions. what's the value of best fitness when we first start?
0.
No?
10, right?
No?
No.
The max.
10.
No? Max? Where do you see that?
So max value.
Up here. So what number is that?
2 billion something.
2 billion something. So as long as the best fitness we've seen so far is higher than our goal, which was 10, we're going to keep doing this. So this removes everything, this basically clears the canvas, clears the board. Print out the generation number, increment it for the next time. What does this do?
Stores all the best counts for each row in an array.
Okay. What do we give it?
Top floor.
Function is the best function. Or,
So run test has 2 inputs and it returns something. What do we give it?
We give it the function and then we give it the fitness for the best one, the number for the best one. So if we compare it to
Give it the old array, funcs,
And what does funcs contain?
all the functions from the previous generation.
No? What does it contain right now?
100 random functions.
100 random functions. Good. And what was best count?
the 4 best.
How many we want to keep? So we give this 100 random functions and we tell it how many we want to keep.
Oh, so we can change that to 4 or 5 to more than?
Yeah, that's just a constant up at the top of the program. So this runs all the tests, and it gives you back an array list of this thing called function fitness. Function fitness is a class down here at the bottom that just holds a function and what its score was. So it just takes a function and matches it with its score. Where were we? Here. So if we ask it to give it back 4 of the best ones, in the process of figuring out which are the 4 best ones, it will have sorted them. So it means, where is the absolute best one so far?
Front?
The front?
0.
It'll be in 0. So that's what I do here, is I get the absolute best one. It must be in position 0. And I just remember what those are, because when I want to know whether to finish this whole thing, I want to know whether the very best one is less than my fitness score. So I run through that array of the best function fitness combinations, and I pull out the functions themselves. And then I say, give me the next generation functions based on the 4 best ones. So, next generation, this is probably where you could go and mess around with stuff. You're given an array of functions, and you're expected to give back an array of functions. So you're going to be given 4 functions, and then from that, produce a whole bunch of offspring. So this one generates 30 offspring by taking 2 of the functions, finding sub-expressions, and copying one into the other. So it's swapping genes with...
You're mating.
Yeah, they're mating. So 30 of those that are combinations of each other. And then, let's see, what does this one do? Oh, no, I'm sorry. This one is 30 of them that it takes one of the 4 best, identifies a spot in there, and just swaps in a random expression to stick there. So if this was one of the best ones here, it just finds a spot, swaps in something else.
Randomly finds a spot.
Yeah, randomly finds a spot and randomly generates something here and just sticks it in. This one down here is mating them. 20 just completely new ones, no relation to any of the other ones. And then 20 of them where I just go through the best ones and I just twiddle some of the numbers. So the operations are the same, the numbers are just a little bit different. So generate 100 new ones from the 4 best ones. And then run it again. And then something else you'll want to mess around with is this, the fitness function. You're given the path that a function took on the screen with a bunch of points. You're given where the targets are, and you need to figure out what was the score. So you might want to change that stuff. So there's basically 2 places in here where you'll want to change things. How you generate the next generation, and how you calculate the fitness score. And the goal of this is to make it as small as possible. So if you want to switch things around so it makes it as big as possible, you have to find the place in the program where it's trying to find the smallest one and flip it around so it finds the biggest one. Alternatively, how can you turn finding the biggest one into finding the smallest one?
1 over.
Did you get that? Just take the reciprocal of it. So again, like let's say you're playing a game of golf, and you're playing a slightly different game of golf. The goal is to maximize your score in golf, not minimize it. How can you play the exact same game of golf, but maximize your score?
Putt the entire
Yeah.
ball and go for sand traps and
No. Same game of golf.
just change the way you
Oh.
keep score.
Just change the way you keep score.
Oh, that's so fun.
So if the goal in golf is to make the score as small as possible, you can just reciprocate the score, and now the goal is to make it as big as possible.
But with a fixed copy.
Putt in the wrong direction.
I might know that, I'm going on the tour. Change
You're like, all right, guys, we got 10 points, reciprocal golf.
Basketball. The goal is to make it as small as possible. Well, just score as many points as you can and take the reciprocal of it. Horse racing. The goal is to be the last one across the line. No, that's completely different reason. How would you play that? The goal is to be the last one across the line.
Just run the opposite way.
The real question is,
Get
how
off
do you
your horse
determine
and
who
shoot
the
it.
winner was, and more importantly, when the winner was?
If that happened, wouldn't everybody just sit there?
There's slow.
There's a bunch of horses
Yeah.
milling around outside the gates.
With a wind on the back.
The jockeys are all sleeping in the stands.
Throw a carrot across the line.
There is that bike race you're talking about where the goal is to be the first one across the line, but really it's actually a game of being the second one across the line until the last moment.
Yeah.
Because you will not win by being in the front the whole way.
God, I think I've seen that. It was ridiculous. Do you know the name of it?
What is it?
Pursuit, I think.
It's a bike, like
It's a sprint race.
Yeah,
So-
the first half of the race is so slow, and then right at the end they all break into this super fast racing. It was on.
It's actually fun to watch.
the
You will not, the goal is to be the first one across the line, but you will not win by being in front the whole time, because in cycling, if you know about drafting, where you can be behind someone else, the person behind the leader is probably expending only about 80% the energy the leader's expending. I mean, you can say, don't try this on the freeway, but you can actually increase your gas mileage quite a bit if you get behind a semi-truck and you go basically bumper to bumper.
They don't like it when you do that.
You'll reduce your gas mileage, you'll increase your gas mileage by about 20% by doing that. It'll save a lot of fuel. What? They do it there, right? But with a car, it's, you know, you just push
Yes,
it.
but in NASCAR, they also don't have headlights to reduce weight, so.
So in cycling, you don't want to be in front. You actually want to be second. so that you can use less energy than the person in front, and then at the very last moment you want to pull ahead because you've been storing up your energy, you've been saving your energy. So it's really a goal for most of the race to be behind the leader. Well, what does the leader want to do? Want to get behind you. So for the first half of the race, you're just crawling along, basically side by side.
And everyone's peeling?
What? There's only 2 racers on there.
Well, yeah, but they just keep peeling back.
Yeah, trying to get behind the other person.
They'll sit there and they'll
I think it's
stall for
better
like an
tomorrow.
hour, like just keep the bike completely stopped. It's
Right.
just
I was trying to
holding
make
it.
bikes
Well,
that
they have a
are
rule
motorized.
where you can't stop. And on those bikes, you don't want to stop because
No, they
If your
stop.
feet are stuck to the pedals, you fall
you're stuck
over.
to the pedals, you'll fall over.
That's the whole thing, is they can't fall over, they just sit there and they stop the bike. I mean, it's crazy, yeah, but they'll stop the bike for like 2 to 3 hours and just sit there and endurance
I
race
think
each other.
at the Olympics, there's a rule, you have to keep moving,
Okay.
because otherwise you'll be there a long time. But then at some point, you realize, now I've got to get in front in order to win this thing, and then they just take off. So it's basically, it's like 2 laps of just who can go the slowest, and then 1 lap of just all out. But every once in a while, you come across a racer that thinks he or she can actually pull it off and be in front the whole time, and then the whole race is just going as fast as they can.
See, I think they need to make it more interesting by switching the way it works so that you have to pedal backwards. So that when they get really excited, they start pedaling the wrong way. Think about it.
All right. So this is the file I'll give you. I believe I've already posted it, although I made a few changes after I posted it, so I'll post a newer version. But it's basically this. So the things that this relies on is it relies on a class called function, which you need to provide, or yeah, an interface called function, because those are all over the place. And it relies on being able to call certain things in your function, like it needs to be able to call